All right. How y'all doing out there today? Sweet, sweet. And you're not. I'm on a working on the Mac today. Actually, I tweeted out today. I needed a whiteboard program, and somebody Excalidraw. This is dope, and it's an open source project. So check it out. So I'm gonna be doing this whiteboard action today with this thing. This is dope. All right, so I'm going to be going for like 50 minutes straight. I had a prior commitment that I have to do at the top of the hour, so I'm going to do that. So I'm going to hop off. I got to do an interview, a book club interview. So all right, so hey, if y'all notice this, and I want to give it some props here. Anybody notice something different? Look at this. Some people have been asking for the cursor. So I figured it out. All right, so let's get in here. So again, also the problem was I was doing the wrong capture. I was doing probably like window capture or something, and that didn't work. So what I did is display capture, and I captured that whole screen. Now the whole screen, you can see the cursor. So that's what was going on.
Motion detected at the backyard.
Nope, the Twitter thing is not. It's not. Not the quarantine sec on Twitter is not. That handle is locked up, and they're doing something. Let me turn down Alexa. My house got like tons of echoes. All right, let's get busy. So what we're doing is we're using this pretty cool whiteboard thing. And what I wanted to cover today, I prepared a little bit of content here already in this whiteboard, just testing the whiteboard out, and I'm pretty happy with it. It looks pretty dope. So today, I want to try to cover some networking. And so I pre-populated this dang whiteboard thing. This whiteboard is freaking dope. Look at all the stuff I put on here. So I actually drew all these things today, playing around with it. The name of this application is Excalidraw. It's up here. I mean Excalidraw, like Excalibur, but Excalidraw, and it's an open source project. You can download your own. It's dope. All right, so let's get down to it. So one of the things that people said they had a hard time with, like I said, I'm trying to spend my time getting everybody the hard stuff, and trying to make the hard stuff not so hard to understand. So and also thanks to everybody. Thanks everybody for showing up again, and we're about to go. We're about to do this. What's cool about this like I said, this whiteboard app allowed me to do this, and it's pretty easy to update and type stuff. All these images over here, I drew them out with the little drawing tools up here on the top. So I'm going to be able to visualize more. I love whiteboarding when I'm talking about stuff. All right, so we're going to talk about class. We're going to talk about addresses, address space, IP address space. Of course, this is IP version 4. And but this stuff is still super relevant. And super relevant. And most of y'all need to know this stuff. So I'm gonna go over these addresses. I'm gonna go over private addresses. I'm talking about loop back a little bit. I'm gonna talk about subnet in a little bit too. Hey, get out of here, booger. My dog coming here. Hey, get out. Get out, booger. Hey, go. Get out. That little criminal right there. She just killed a baby squirrel. She's mean. It wasn't like an adolescent squirrel, but she killed the squirrel. The little crazy dog. Alright, so, and I'm drawing these network things over here. So these are network icons that everybody should kind of know. So what you're going to see throughout your career in internet networking and cybersecurity, you're going to be seeing network diagrams. And these are classical diagrams that I drew in here. So this is like any kind of appliance. You're going to see weird looking appliances. I drew a magnifying glass on here. So that's a super generic. This is as big as I can. Oh, this is pretty big. This thing is dope, man. This freaking whiteboard is awesome. So firewall, router, switch, workstation, server, a laptop, and if you see a cloud, it's usually a network diagram. And this is a database, and so that's pretty much what we're gonna go with. So these icons will allow me to draw pretty much when I'm talking about stuff. It'll let me draw that out, and I'm gonna have a ball here working with this little software because I can copy and paste it and put it on some. The whiteboard is infinite size, by the way. That's stupid, man. It's freaking awesome. You don't have to delete the whiteboard either. This would be good for work. All right. So anyway, so basically these addresses. This is what we call this is what we call this is we call it excuse me, dotted. Whoops. You can actually have a couple of different fonts up here too. What the heck? This went away. So dotted decimal notation. I'm pretty sure that this is what this is called. Hand drawn. I can do code. So this is all dotted decimal notation. What it means, it has decimal numbers and it has dots. As we know, all these different things, all these different things derive from bits and bytes. And so here we see that this right here is 8 bits up top, and that makes a byte. And so if you add all these bits up, these are the bit values, right? And the highest, and if you add all these numbers up, these numbers equal 255, right? So if we were to put this, every IP address that you ever see is essentially 1, 2, 3, 4, 5, 6, 7, 8 dot. Every IP address that you could ever make looks somewhat like this. This is the binary equivalent to those IP addresses. So when I say, so this wouldn't be dotted decimal, this would be like dotted freaking binary. What's cool is you'll see somebody do parlor tricks, and I call it a parlor trick because what you can do is you can actually type in these two, you can like 1.1, and then you could actually type in some form of this plus this. So that would be super hard to remember. So what we do is, instead of doing bits like that, what we end up doing is we end up saying 1.1.1.1. And if I did this up here, this would be 1, and that'd be 1, and that would be 1, and that would be 1. So that's the exact same equivalent as that. So dotted decimal notation makes it easy for us to remember these IP addresses, right? So as you see here, what old school, this is classical, what we call class full, and basically what they do now is they introduce something, I think around 1983 or something like that. It's a new standard, which these classes don't mean as much as they used to be. However, in order to ensure backwards compatibility, you need to know what these things are. So you see a lot of 255s here. I'm going to talk about network mask here now. So basically, these are the address ranges. And what I'm going to do here is I'm going to give you the network mask, the traditional network mask. So basically, Class A is a stroke 20. Class A is a stroke 8. Class B is a stroke 16. And what this means, I'll show you what this all means in 2 seconds. Class C is a stroke 24. So for now, this is what I'm gonna basically these are the default net mask for these different ones. And watch how easy this freaking thing. Whoever wrote this, man, I gotta donate to this project. This is freaking dope. This is the dopest freaking thing I've seen in a while. So those are the net masks, and so those net masks equal to 255.0.0.0, and this one is equivalent to 255.255.255.0. My bad, 0.0. This one is equal to 255.255.255.0. Now, what I want to do here is explain this real quick. So we said we have this Class A address, right? So we're gonna just put this. We can put this up here for a second. Watch this. Man, I love this program. So basically, what this means is, remember I said all these bits over here on this. Whoops. All these bits right here are a total of 255 decimal. So if that means if we put all these ones here, that would be that. Now that's how you get a network mask. That's why people say stroke 8, stroke 16, stroke 24. Because what they mean is the first 8 bits, in this case, this would look like this. 111, 111, 1.0.0. You know, and you get the drift, right? And so basically this one would be equals to this 1.1.1. Whoops, my bad. 111, 111, 111. That's what that would be. All these are zeros. That's why I'm not gonna put them out. I'm just gonna put all the ones. All right. Let me just copy and paste this real quick. So now why this is important is because remember how we break everything down to the physical layer, right? So basically, if you along the wire, this is what these would be. These would be like, definitely if you're talking about fiber is usually, people say fiber is represented by on light or off light. So that on light would mean that these are the network masks. Now I'm going to tell you, let's get the reason why this is super important. Now why this is super important is because there's this thing, the net mask actually determine how many networks and how many hosts that there can be on a network. Now, why this is super important, back in the day, these addresses used to cost money. So if you wanted a Class A back in the day, that would have cost you thousands of dollars. And people have sold these sold these address spaces for a lot of money, because there was actually a shortage of them, and so people started selling these off after they had ownership. So they pretty much, the government allowed, I believe it was the internet, to issue these addresses, and I got a dead pixel on my screen. That's a dead pixel. That's crazy. All right. Maybe it's the dang thing. I'm crying over here a little bit. So so basically what this is this is a remnant from the old from the old days in IP address space, because there's something new. It's called NAT, and that's what NAT uses. NAT is not super new. I'm going to explain that in a second, and why this all matters, right? So there's private addresses, and we use these private addresses on our internal networks. Here's how the private addresses look. And so you notice here that the 10 is super popular. People use that a lot. This space is pretty popular. The 168 space is super popular. You see this used from time to time. It depends. I wonder what that is. I'm concerned. I'm like, why am I seeing a dot there? I'll figure it out later. Maybe I accidentally put a dot there. All right. So, let's back up a little bit. So basically, the networks go this way, and the hosts go this way. Now, how to explain this is, if I took the IP address, this is one you'll see a lot. .0. I'm going to say that's a network address, right? Now, the network, this network address by default, you see up here it says Class C. So 192 by default is a Class C space. And I also said that a Class C hopefully I'm not making nobody motion sick here. Class C, this is freaking dope. A Class C address space is the first three what we call octets. An octet is another nice word for byte. So Class A, the first octet. Class B, it has 2 octets that define the network. And Class C has 3 octets that defines the network by default. So by default, this is your home network probably. Now, the first address is called the network address. And there's another address on here that's important. This one is called a broadcast address. Now, why this is important, if you look up here, there's this formula that I have here. Whoops, and drop my little ends. Let me move my little ends into place. So, basically, to calculate the number of hosts that is possible on a network, what you do, what you can do here is you can say this is the number of hosts, and you can and this is the number of networks. So by default, most devices are 196, 168, or the one that brand. I've seen 10s, but most of the time I see 168. I see that more consistently. I don't know why people do that more consistently, but I see it. So basically, now this address, this network address, you might see it as a stroke 24. Now, what that means is the first bits going this way, right here, all those ones define the network. Now, why this is important? The thing that I use is I say I have a concept of houses. Or let's say we have a concept of bars, right? So say if this is a bar, and every bar has occupancy, right? I mean, there's some kind of city limitation on it, right? So now, if you had occupancy right here for this network, the occupancy of that. In humans, we like like a fire department would come out and they would say, "Hey, you can only have this many people in this house or whatever." So what you do is that you add the number of hosts because it's a Class C. The maximum people you can get in this room here are 253. Because what you do is you take 2 to the n minus 2, and remember the first address is 0 and the last is 254. So you can have 254 hosts. And actually, let me just do this. Let me get my little network thing. You can have 253 addresses on this Class C network. Whoa. So the possible addresses are 192.168.1.1 to 253. Now what you'll see in a lot of networks is you'll see that you have to have a default router, and most of the time your Wi-Fi in your house, my bad, I said 254. I said 253, but it's 254. So basically, those are the options. And typically on your network, yep, 0 can be 1 too. So basically, you need a way to get out of your network, and that's going to be your router. So let's start drawing a network. Let me grab a router, and we're going to start drawing this network out. Alright, so we got a route over here. And let me grab a laptop here. Now, most of the time, how you get out to the internet, and what's cool about this, on this side, what I'm going to do is I'm going to draw this cloud, and I'm going to draw this cloud on this side of the network. Because this is how, when we draw network diagrams, we represent them as clouds, typically. All right, so let's do this. This is your home network here. Typically, to get out your network is typically, and this is like the standard, the IP address on the inside of here is going to be either the highest or lowest number. That's like pretty standard, right? And typically, the first machine that joins after that it's a protocol called DHCP that is going to be in your keywords. Your router is going to run DHCP here, and that stands for Dynamic Host Configuration Protocol. And what that's going to do is it's going to assign all the devices on your network an IP address, an internal IP address. That's cool. So now, between your router here, and it most of the time there's actually it's what I'm gonna it's an ISP that's gonna be here. So we can actually just draw the ISP cloud. Whoops, hold on. Oh. All right, so let me try to grab the cloud, paste it. So this cloud out here is going to have a big cloud, and this is going to be your ISP most of the time. So say if this is ISP. Now sometimes your ISP, they'll give you a globally routable address. I'm going to totally make up an address here. I'm going to say 58. I'm going to say 28. My bad, I can't type. So your ISP can give you any address that they want to. What's funny, sometimes you might see an ISP give you a private address over here. I have seen that before. This is your ISP's cloud. A lot of ISPs have tons of IP addresses, tons of different infrastructure, and they might be running IP version 6 on the inside of their network. Now, why this is important, if you're at home, typically there's a limitation on how many addresses, there's a limitation on how many, you could only put 253 machines in here. There are exceptions, I'm not talking about exceptions. You can create another network, of course. But the most machines you could ever have on this network inside of here are 254 hosts. And that's why you need, in a network, you need more space. So what you would do is you could do two things. You could actually do a subnet, or you could just create another network. So, but what's crazy about this, what's cool about it is this network and this network, the machines on this network can never talk to the internet without being routed. And what we talk about routing protocols. Like this machine, it doesn't know how to get to this IP address right here. And so say even if Google or something's over here, so say if Google existed over here. Because Google is not on your home network, you need to be routed to Google through your ISP. And that's how it goes. But let's talk about subnetting, right? That's the maximum amount of hosts that you could ever put on that Class C network. Now, why subnets are important is like I said, ISPs, what they get paid to do is they actually have to have globally addressable IPs. And so what they'll do is they'll do something pretty cool and slick. And so let me look up here and see a good space. And this is a good explanation of why people do subnetting. And we call this variable lit subnet masking sometimes. So let's look up here, a Class C address. So we can pick something around 200 to have a fake IP address. So I need to have 200 dot whatever. I'm changing this. So my this is my internet router. This is my router at home. My ISP gives me this. The ISP has to service hundreds, if not thousands, if not millions of people, right? And there's millions of IP addresses. However, for a Class C address, they need to carve that space up. And so what you'll see in some cases, you'll see point-to-point IP addresses. And what point-to-point means is that we're creating a network where only like two hosts could exist. And I'll show you how this works. So, and then you're going to have to subnet to get that. So in this case, the network is 200.1.2.45. Now this might be even a wrong. This looks like it might be good, just looking at it, but I'll show you how that will work. We're going to subnet down, and this is why subnet matters. If I said this was a stroke 24 network, this would be kind of a waste of space. However, sometimes you will see this on a local network. You might see bigger address spaces. But let's just pretend that, look, we want to serve. We want to conserve IP addresses if we're in the ISP. Now, if you're working for a company, you're going to have to do this probably too, because you're going to have point-to-point links sometimes. Now, how you would do this is you would have to sit down and you have to break this up into different networks. Now, we said the number of hosts is calculated this way. And we also said that the number of hosts is 2 to the n minus 2. You can't have a subnet. You can't do these two. So the first one you could do, minus 2, Am I right here? I think I'm right here. It is this address right here. So you have to, the subnet for this would have to be -3. So what's that? Help. Am I all right? So 1, 2, 3, 4, 5, 6. So it would be a stroke 30 address that you would give it here. Now that stroke 30 address space, if we take it all the way down to here, I'm going to say that's going to be the network address. The first host on that network would be .1. That's the network address. Over on the ISP side, that would be on my router. This would be 2 right here. And the broadcast address would be .3. I'm going to take questions in a second because this is going to get confusing as a mug for some people. So basically this link right here is a point-to-point link. And the reason why this is important on the internet, you really, in some cases, you really have to have real IP addresses that you can route globally. Now what they do is they do this variable length subnet masking so they don't burn up all their IP addresses. ISP, because they really have to pay for them. All right, I'm going to pause here for a second. So this is going fast. Yeah. So let me. I'm trying to take out a plausible scenario here. The plausible scenario is on your internal network you have 254 hosts, but an ISP, they can't spin a whole class C on just your internet connection. So your internet connection, say if a class C address space costs $10,000 on the market, and it could. I don't know what the numbers are right now, but you can probably Google it and you can find this out. So what we're doing, the ISP will buy address space, right? And instead of saying that this is a stroke, so the typical, this would be the subnet for this typically. What that does is it burns potentially hundreds of hosts on that. So what you do is the new subnet that I'm going to give it will be 255.255.2. What do we say? Is it 240 or is it 252? That's 252. Yeah, I think that's it. Is that right? Yep. So that's the original. This is the classic one. This is variable length subnet masking. Now what this is again is the save space. To save IP address space so they don't have to blow it all. Right? Alright, $25 US per IP address. So somebody looked it up, that's like $6,000 per class C. So just think over time that's going to be a lot of money. So yeah. And you know, like if you ever played around before and you get your own dedicated IP address, ISPs, they sell these things, right? So stroke means this is how many bits that you're grabbing. So it's represented in several different ways. So this means this is a 30-bit subnet mask. right? So watch this. So I'm gonna draw this out. I'm gonna show this out. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. That's what it looks like. That's what that subnet mask is in binary. So there's a couple different ways to say this. Some people would say stroke 30. Or we have this, those all mean the same thing as this right here. So there's different ways to say it. You can say slash or stroke. I say stroke 20, stroke 30, slash 30. But this is like slang. So you guys learn how other people say it. So basically, anytime you see this number is indicating how many bits are for the network. This is kind of like crazy to. This is like somewhat hard, but what we'll do is we can revisit this and please in the dang in the Discord, make sure that y'all help out your fellow colleagues here. But why this is all important is because when you start doing like networking and say incident response, you're gonna have to know what some of this stuff means. All right, so we're talking about this is getting into it, and hopefully we can keep on going. But this is super important to understand. All right, so let me. I'm gonna simplify this a little bit more though. That's super high level, and that's the reason why you would do it. ISPs do it, and businesses do it, so they don't have to spend a lot of stuff. They don't have to spend a lot of money on it. So I see people saying they're gonna go off and do some research. You definitely need to go off and do some research on it. And I'll work with more examples to show you why it matters. All right, what I'm gonna do here is I'm gonna go down to layer 2 real quick, so you know how that works. I'm gonna talk about how routers work and how firewalls work and all that stuff too. So let's start off with switch though. All right, so on your network, your networks are connected with switches, typically, or in the wireless world, your Wi-Fi hotspot or whatever does the same task. I want to make these two different IP addresses. All right, so basically what we said before is we said there's a MAC address on every machine. Is that a MAC address? That's the right length? People's, is that the right one? I think that's right. Is that right? Is that close? It needs to be 12? 1, 2, 3, 4. Alright, my bad. Oh, my bad. Here it is. I'm stupid. Like this. Something like that, right? Is that closer? Somebody gave me a good example. I'm getting confused on the ones and twos here. Hold on a second. I'm gonna show y'all some stuff that some people is gonna blow your mind first time you try to understand it. Because I think it's crazy, and I think a lot of people don't understand how this works too. So if we just change just the last digit here, what we have here is these machines, they would not talk to each other by the IP address if they're on the same, what we would call, and if you're gonna see this term, you're gonna see a LAN or you're gonna hear VLAN a lot. This stands for virtual LAN. These machines can talk to each other, but to talk to each other, they're gonna have a quick conversation. They're gonna this machine right here is gonna say like 812. No, it's gonna say I want to talk to 12, right? So it's gonna send an ARP request, and somebody on the network is gonna say, hey, 12's 12's ARP MAC address is this. And so this is like when like you have a friend, like I had one of my colleagues named Jennifer. Like sometimes, you know, when you ask somebody, hey, what do you prefer to be called? And some of y'all probably call me Butch, right? So it's all like this. And basically you send out an ARP request, and anybody on the network can say, this is that address. And all the machines on the network, if they want to talk to the local machine, they will just talk to it by this, and they keep this thing called an ARP cache, and they know how to talk to each other. So that's awesome. But if I'm gonna say .12, right? And I'm gonna say dot. So basically, this is saying if they want to talk to each other, they're going to do an ARP request, and then they're going to exchange information because it's on a local network. This is layer 2 communications. Layer 2, and we call this this is called switching. It's called switching because it switches. Is exchanging information with the MAC address. Right? Now, as long as you're on the same LAN, that packet is never going to change. Right? Now, if you want to add a router in here, so if this person changed their address, and I'm going to just change this to 2, these machines can never talk. And somebody mentioned this. There's what on Cisco calls this thing called a CAM table. A CAM table allows the switch to keep a table, and that table is going to look like this. It's going to look like a routing table, and it's going to keep that in there like this. So the switch can actually do the local, as long as you're on the same LAN. So say if this was 13 and this was 13, a switch is keeping all the MAC addresses, and it's actually allowing people to talk on the same network. And so that's how you talk layer 2. Now, if you wanted to talk to somebody off your network, you have to have a router. So you can set up a network all day, and it's never going to go anywhere. You cannot connect to anybody outside your network. So you have to have 2 things. You have to have a switch that's capable of understanding layer 3, and some people call it a layer 3 switch. And the real truth is all routers are layer 3 switches. Any router that you see is a layer 3 switch, even the old school ones. Because what they do is to get to the next network, they have to change the MAC address. So every hop on the internet, the MAC address changes. So if I talk to my local router, I'm going to put source and destination IP address on there, and I'm going to say you're my default gateway, and I'm going to send you this packet. But when the router has the switch send it to the next person, it's going to rewrite that frame to have its source MAC address in the source and the next hop's MAC address. So locally, we only communicate by MAC addresses. Let me change this one so I don't get confused. So I'm gonna have to dip. I told at the beginning here. I agreed to do this interview. It's like a book club online. I agreed to do it like 2 months ago, and today is the day that it popped up on my schedule. So I gotta go. We're gonna be diving deep into this. Deep into this because this is cool stuff. And this right here, again, I like stuff that's green, this evergreen. When you understand this, you're going to be able to do this super well. All right, so homework 2.1 and 2.2. I'll be here Thursday for the whole time. Hey, did y'all like this whiteboard? Is the whiteboard good? The homework is 2.1 and 2.2. All right, so I'm going too fast, Chris. All right, so sometimes what I gotta do is I gotta go fast sometimes to show y'all the big stuff, and then I can kind of hopefully break it back down. Okay, so stick with me. Do some self-study, read up, and then hopefully some of the concepts that I'm showing you will make sense. Because in a potential interview, what you may have to do is you might have to do some of this stuff. You know what's crazy? I can actually export these, by the way, guys and girls. I can export this. So let me export this and try to see if I can put it on Discord, okay? So I can save it right here. Man, this thing is money. This is money, this thing. So name this application is right here. It's like Excalibur, but Excalidraw. If I click on this, here's you can download it and use it yourself. It's crazy. God dang, this thing is money. Check that out. Shout out, hey, man, I actually give a shout out to whoever on Twitter, whoever showed me this. This thing's money. All right, y'all. Y'all take care. Yeah, I have a website. Go to the .com. You go to the .com and you're automatically into it drops you right off into a drawing. So I got all fancy and did all this crazy drawing. It started off with a clean white slate, and I did all this other crazy stuff. It's gonna help us out big time. All right, y'all take care. I will talk to y'all Thursday. Bye-bye.